Good morning, students. Today, topic 2, properties of system from thermodynamics lesson. In this last class, we have discussed about system, surroundings, boundary, as well as isolated system and open system, closed system. So, the system also classified into so many types. The first one, the properties of system. The properties of system is extensive property, intensive property, state function as well as path function. Extensive and intensive properties. What is extensive and intensive property? The property means a characteristics of a material. Material may be a system. The properties are divided into two subtypes, extensive and intensive. So extensive properties are based on how much of material you have, and intensive property are not based on how much of material you are having. So we can explain more the intensive and the extensive properties. The extensive properties, it is depends on size or mass of a system. Intensive properties are, it is independent of size of the system or mass of the system. Which is extensive property, which is an intensive property. So we are using volume, the system volume, mass, total energy, enthalpy H, entropy S, and free energy G, as well as heat capacity. These variables are considered to be an extensive property. It is depends on size of the system. Suppose if you are taking a water, isn't it, in a tumbler or in a water can. So the size may be depends upon the size of a tumbler or depends upon the size of a water can. So the water is a system. That means that it is depends upon size of a system or mass of a system. So, but intensive properties, it is independent. The temperature, this pressure, as well as molar volume just be independent of a system. This is known as intensive as well as extensive property. Next, we are going to see state function, the state variables of a system. It is state function. What is state function? It is depends only upon the state of a system and it is independent of a path by which the state has been reached. One example we can see, suppose a person standing on the roof of the building has fixed value of potential. He has some potential energy, and the potential of a person does not depend whether he has reached there by stairs or lift, isn't it? So the potential energy, we can see some examples. Potential energy, pressure, volume, temperature, as well as internal energy U. Not only you can imagine, you can memorize PVT. The PVT is what? Pressure, volume, temperature is a state function. It is independent of the path function. So I shall give more examples for the state function. Suppose you are traveling from one place to another place. You are considered you are a system. A state function is defined the property of a system that has depends on the initial and the final state of the system. This is initial, this is final. Okay, these two are said to be a state function, right? And suppose you are traveling from one place to another place. The initial place is here and final place is here. In this, we are going to calculate what will be the system. What will the pressure of a system, volume of a system, temperature of a system we have calculated here. At the same time, it will be reached here, the final. So, it is also going to be called what will be the pressure, what will be the volume, everything. These two are said to be a state function and it is independent of a path followed. Suppose if you are traveling from one place to another place, it means here initial to final, you can choose a straight line. Or sometimes you can choose a different pathway, isn't it? So you can choose different pathway or you can choose straight line. This is said to be a path function. This is said to be a path function. So the state function, these two are, it does not depend upon this path function. The path function may be differ. You are going to in straight way or sometimes you are going to different pathway. So it doesn't matter for the state function. So it is independent of path followed in getting from one to another. This is known as state function. Path function. Next one variable is path function. A path function depends on path followed in getting from the initial to the final state. So you are traveling or you are traveling through the bus, you are traveling through bicycle or you are running from one place to another place, you are choosing some other pathway, that is known as path function. This path function we can see it may be work or Q. Work or heat. W work and he is heat. Suppose we can see, suppose a system is traveling. A system, you can imagine the A traveling. So A to again it gives B. So it reaches B. So these two are, we said it is a state function. Isn't it? So what will be the pressure, volume as well as temperature as well as internal energy U as well as H is enthalpy as well as H as well as G. So we can see these are a state function, and in this pathway, so what will be the work of the system and what will be the Q? That is a heat of the system. So W as well as Q can be calculated. These two are said to be a path function. This is path function. So suppose the system can be raising the work, automatically the Q will be also increased. When the W will be increased, so the Q will be also increased. Suppose the work will be lesser, the work is decreased, automatically the Q will be also decreased. The heat is also decreased. So the W as well as Q is known as path function, as well as here A as well as B is a state function. So the state function, this is state function. This does not depends upon a path function. So we have many state variables for state functions. Pressure, volume, temperature, as well as U is the internal energy and H is the enthalpy and G is the free energy. As well as the path function, two variables. Only is W work and Q is heat. What will be the work and what will be the Q in between the initial state of A as well as the final state of B. That is said to be a path function. So students, in this lesson we have discussed about extensive property, intensive property as well as state function as well as path function. So we shall see the next topic in next video. Thank you students.